Welcome to episode 35, Vertex AI and TensorFlow at a glance, where we look at how Google Cloud's machine learning platform and framework work together to simplify, scale, and industrialize artificial intelligence. Vertex AI is the managed environment for building, training, and serving models, while TensorFlow is the open-source framework for designing and running them. Together, they form a complete ecosystem, from experiment to enterprise deployment. For teams, this pairing means less time maintaining infrastructure and more time improving performance. Vertex AI supplies orchestration, governance, and monitoring. TensorFlow provides flexibility and mathematical depth. Whether you are training a deep neural network or managing hundreds of models, understanding how these tools connect helps transform machine learning from experimentation to reliable production capability. The Vertex AI workspace brings all essential components into one organized interface. Within it, you can manage datasets, notebooks, models, pipelines, and endpoints without jumping between tools. This integration matters because fragmented workflows often lead to version mismatches, hidden dependencies, and unclear ownership. The workspace consolidates oversight, giving data scientists, engineers, and operators a shared environment. For example, a project might use Vertex datasets for input, Vertex pipelines for processing, and Vertex endpoints for serving, all accessible in one console. This cohesion reduces friction, improves transparency, and ensures that every experiment and deployment step is traceable. In essence, Vertex AI's workspace serves as both laboratory and factory floor for machine learning development. Notebooks and managed workbench environments within Vertex AI provide flexible, ready-to-use resources for experimentation. Instead of configuring local environments or managing dependencies, users launch notebooks preloaded with libraries like TensorFlow, scikit-learn, and BigQuery connectors. The managed workbench handles scaling, access control, and persistent storage. For instance, a data scientist can prototype a model in TensorFlow within minutes, share it with teammates, and move seamlessly into a pipeline for automated training. Workbench instances can attach GPUs or TPUs for acceleration and pause when idle to control costs. This setup preserves convenience without sacrificing governance, allowing creative exploration inside a secure, standardized environment that integrates with enterprise data and compliance requirements. Vertex pipelines ensure that machine learning workflows are reproducible and auditable from end to end. Pipelines define every stage: data ingestion, pre-processing, training, evaluation, and deployment, so results can be repeated with precision. They are built using Kubeflow pipelines or TensorFlow Extended (TFX), both fully supported on Vertex AI. For example, a fraud detection project might automate daily retraining using a pipeline that collects new data, validates features, retrains the model, and redeploys the endpoint automatically. Pipelines also record metadata for each run, simplifying debugging and compliance. Reproducibility matters because untracked experiments lead to wasted effort and inconsistent outcomes. By treating ML workflows like production code, Vertex pipelines turn ad hoc research into a disciplined process that can scale confidently. The feature store within Vertex AI provides a consistent, governed source of input data for training and prediction. It ensures that features used during development are identical to those used in production, preventing the common issue of training serving skew. For instance, a recommendation model trained on normalized purchase data must see that same normalization logic when predicting in real time. The feature store centralizes feature definitions, manages access permissions, and supports versioning. Teams can reuse validated features across projects, improving efficiency and reducing duplication. By maintaining feature lineage and consistency, the store strengthens governance while boosting speed, enabling machine learning models to operate with trusted, stable inputs. The model registry in Vertex AI serves as the authoritative inventory of all trained models, linking artifacts, metadata, and deployment history. It simplifies version control by tracking metrics, owners, and status staging, production, or archived. Deployment options include online endpoints for real-time predictions and batch jobs for offline scoring. For example, a churn model can run continuously for website visitors through an endpoint, while another version processes monthly data in bulk. This separation lets teams match latency and cost requirements precisely. The model registry also supports rollback and comparison, making experimentation safe. Centralizing model management eliminates the confusion of scattered versions, ensuring that organizations know exactly which model is making each decision and why. Vertex AI supports both online and batch prediction workflows to cover diverse operational needs. Online predictions respond instantly to requests, ideal for personalized experiences like chat responses or fraud checks. Batch predictions process large volumes of data asynchronously, optimizing cost for non-urgent workloads such as nightly analytics or mass scoring. Each method uses the same deployed model but different compute strategies. For instance, the same TensorFlow model predicting credit risk can serve live applications in real time and rescore customer portfolios overnight. This dual approach maximizes reuse and minimizes complexity. Teams can blend modes seamlessly, batch for trends, online for moments, creating continuous intelligence across the business lifecycle. Monitoring in Vertex AI tracks model health through metrics such as prediction drift, input skew, and alert thresholds. Drift monitoring detects when live data diverges from training data distributions, signaling the need for retraining. Skew monitoring highlights inconsistencies between feature sources. Alerts notify operators when performance drops or data pipelines break. For example, if average transaction size in production shifts significantly from the training baseline, the system raises an alert for review. Continuous monitoring turns machine learning from a one-time achievement into a living product. By integrating monitoring directly into pipelines, Vertex AI closes the loop between experimentation and operation, ensuring sustained accuracy and trust in deployed models. Training at scale with Tensor Processing Units, or TPUs, unlocks immense computational power for deep learning workloads. TPUs are specialized accelerators designed by Google to handle matrix operations efficiently, the core of neural network training. Vertex AI lets you choose between CPUs, GPUs, and TPUs depending on workload requirements and budget. For example, a computer vision model processing millions of images might train in hours instead of days with TPUs. The system handles parallelization, checkpointing, and resource allocation automatically. This on-demand scalability means teams can prototype on small datasets and scale up seamlessly for full training runs. Efficient use of TPUs reduces time to market while maintaining reproducibility through managed infrastructure. Distributed training strategies in TensorFlow extend scalability further by dividing work across multiple devices or nodes. Data parallelism splits input batches among workers. Model parallelism splits the architecture itself, and parameter servers coordinate updates. Vertex AI supports these distributed modes natively, simplifying configuration. For example, training a large transformer model can span several GPUs or TPUs without manual synchronization. Distributed strategies matter because modern models exceed single machine capacity. By combining TensorFlow's distribution APIs with Vertex orchestration, developers achieve near-linear scaling with minimal engineering overhead. This efficiency turns massive datasets and architectures from theoretical possibilities into practical, maintainable systems. TensorFlow provides the framework backbone for developing models, offering intuitive tools like Keras for design and abstraction layers. Keras simplifies neural network construction through clear, modular syntax, making experimentation accessible even to beginners. The saved model format captures both architecture and weights, enabling easy deployment to Vertex AI or other environments. TensorFlow Serving handles inference efficiently, delivering predictions through APIs. For example, a Keras-trained model predicting demand can be exported as a saved model and deployed to a Vertex endpoint in minutes. TensorFlow's versatility, spanning prototyping to production, makes it the default framework for scalable machine learning pipelines within Google Cloud's ecosystem. TensorFlow Extended, or TFX, adds automation for data validation, transformation, and deployment. It enforces best practices like schema checks, drift detection, and pipeline reproducibility. TFX integrates tightly with Vertex pipelines, allowing seamless transition from notebook experiments to continuous delivery. For instance, a recommendation model can be trained daily with updated features and deployed automatically if performance exceeds thresholds. This automation minimizes manual steps and reduces human error, ensuring consistent model quality. TFX also supports explainability and lineage tracking, aligning technical rigor with regulatory expectations. Together, TFX and Vertex AI form the backbone of industrial-scale machine learning, where reliability and speed coexist by design. Vertex AI and TensorFlow together industrialize machine learning delivery, bridging creativity and control. Vertex orchestrates infrastructure, monitoring, and governance, while TensorFlow empowers model design and innovation. The combination converts prototypes into scalable products that organizations can trust, audit, and evolve. By uniting experimentation, deployment, and oversight, teams shorten feedback loops without sacrificing discipline. This synergy turns machine learning from a laboratory pursuit into a dependable enterprise function. When managed through Vertex AI and powered by TensorFlow, artificial intelligence becomes not just achievable, but sustainable, built to deliver insights at scale, securely, and responsibly across the entire data-driven lifecycle. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.